We left off talking about costs in the short run, in particular in situations where we had some fixed inputs. That led to the idea of total fixed costs, total variable costs, and total costs, as well as average fixed costs, average variable cost, and average total cost, as well as marginal cost. All of those are important concepts, but we want to move a bit beyond them and recognize that not all decision making is made in the short run. Indeed, it's quite true that people often make decisions in a long run context. That is to say, when all inputs are variable. When that happens, all costs also become variable. And what ends up transpiring from that is that average fixed cost will equal 0, since there are no fixed costs, and the average total cost curve is really just the average variable cost curve. What I'd like to do here is take a look at what the average total cost curve looks like, how they come about, and what some of the economic consequences of the long-run cost curves are with respect to agriculture. To get at this, we're going to draw 3 different short-run average total cost curves. They're going to be for 3 different types of firms. One firm is small, another firm is a bit bigger, and then the third firm is even larger. We have this red curve that shows the average total cost for some firm that we're going to label A, or a firm that it could be characterized as having a structure like firm A. This other cost curve, average total cost curve, is for a firm that's configured in a different way, and let's call that ATC-B. Lastly, we're going to have this green curve that we're going to label ATC-C that's configured for the third firm that is larger but looks like it's got a higher cost than the other 2 firms. What I want to get across here is that we can actually use these short-run average total cost curves to think about how we derive a long-run average cost curve. To do so, let's think about a firm that wants to produce less than QA units of output. If you were producing less than QA units of output, which firm would you rather be? Firm A, Firm B, or Firm C? Well, it doesn't look like Firm C is a very viable enterprise. We don't actually have the average total cost plotted at that low of a level of output, so they may not be designed or configured to actually produce at that low of a level of output. But Firm B and Firm A could certainly produce QA units of output. Which one would you rather be? If you think about it for a minute and you look at average total costs, what you'd think is that you'd rather be Firm A if you were producing less than Q units of output, and the reason is that you've got a lower average total cost. What about if you wanted to produce QB? Which firm would you like to be? Would you like to be the firm with the red average total cost curve, the firm with the black average total cost curve, or the firm with the green average total cost curve? Well, again, if you think about it for a minute, and remember that we're talking about costs, and firms don't like costs, they want to make costs as small as possible. If you were producing QB units of output, you'd rather be Firm B. And that's because the average total cost at QB units of output is the lowest if you are Firm B. What about if you were actually trying to produce QA minimum? That's the point where average total cost for Firm A is at its minimum. Which firm would you rather be? Would you rather be Firm A or would you rather be Firm B? Well, the way they're drawn, you would think that you'd rather be Firm B, and the reason is that even though you're producing at the point where Firm A has minimum average total cost curve, differences between those 2 firms are such that Firm B has a lower average total cost at QA minimum than Firm A does. Now, this is an important point because this is the driving principle behind how we derive long-run average cost curves. And in fact, the long-run average cost curve is simply an envelope of several different short-run average total cost curves for firms with different configurations and for firms that are designed to operate at different levels of output. All you do is you trace out the minimum per unit cost at which any output can be produced after adjusting for the business's size. We're going to walk through an example of this in a few minutes. But I want you to remember that it's the lower envelope, it's the bottom tracing out the bottom envelope of all short-run average total cost curves that defines the long-run average cost curve. To illustrate this, let's suppose that we've got these 5 different short-run average total cost curves. We've got 2 that are red, we've got 1 that's green, 1 that's blue, and 1 that's purple. And so these could be average total cost curves for 5 different kinds of firms. And what we can see is that if we wanted to produce 8 units of output, we would actually want to be the firm that's characterized by that green average total cost curve, because at 8 units of output, there's no other firm that has a lower average total cost. That is the least cost firm at that level of output. And so if that were the case, what we would know is that point A is on the long run average total cost curve, because if other firms that were producing 8 units of output could adjust all of their inputs, that is to say, if they had all variable inputs, they would want to adjust them such that they would mimic the firm with that green average total cost curve, and they would end up producing at point A. If we think about a firm that wanted to produce 10 units of output, again, we can think about which firm would you want to be. Would you want to be firms that are characterized with those red average total cost curves, or the firms that are characterized by the green or the blue or the purple average total cost curves? Well, again, recognizing that firms are interested in minimizing costs, it stands to reason that what you would want to do is actually produce at point B. And you would want to be the firm that's characterized with the blue average total cost curve. And again, the reason for that is that's the best you can do if you were producing 10 units of output. If there was some other firm that could produce at a lower average total cost at 10 units of output, then it would actually be in the long run average cost curve. But there isn't some other firm that can produce cheaper than the firm with the blue average total cost curve, so it's part of the average total cost curve, but only at point B. Lastly, let's think about what would happen if you wanted to produce at 12 units of output. Well, at that point, you could produce, following the production technology of the firm that's characterized by the red average total cost curve on the right-hand side, or the firm that's characterized by the blue average total cost curve in the middle, or the firm that's characterized by the purple average total cost curve. Well, at 12 units of output, what we see is that the firm with the purple average total cost curve is the least cost firm. And so what we know is that at 12 units of output, the average total cost curve would actually go through point C. We can do this for many different types of short-run average total cost curves. And if at each level of output we identify the lowest average total cost in the short run, those different points define the long-run average total cost curve. And it would look something like this, where that black line is the long-run average total cost curve, and it's just touching points A, B, and C. It's getting the envelope of all of those lower rungs of the average total cost curves. It's not going through the minimum of the short-run average total cost curves. It's getting the lower envelope of all of the short-run average total cost curves. Now, what's important here is to remember that when firms are making these long-run decisions, it's actually choosing a plant size or a farm size, if you want, and it makes other investments to minimize its long-run cost on the basis of how big it wants to be. So if you pick the size of the operation that you want to be, what you'd like to do is actually say, okay, for a firm of that size, I want the least cost production facility and the least cost equipment that would make me an efficient producer insofar as cost minimization is concerned. But once you choose your plant size and equipment, once you make those important capital investments, those inputs then become fixed in the short run, and you can't change them. And so those long-run decisions then lead to your short-run cost structure. That actually has some important connotations with respect to the relationship between short-run average cost curves and long-run average cost curves. So for instance, let's suppose that this was some long-run average cost curve. Well, if I decided that I wanted to produce Q units of output, I'm going to buy a particular amount of capital goods, so it could be land, it could be equipment, machinery, etc. And I'm going to build a facility, a production facility that would allow me to produce Q units of output at the lowest possible long-run average cost curve, cost of production at the level of output Q. Now what that means is that I've locked in the technology that I'm going to use, and so my short-run average cost curve would actually have to just be touching a point on that long-run average cost curve. Now the way I've drawn it is that the firm is choosing a technology such that the short-run average total costs are minimized, and the short-run marginal cost curve will also run through that point. So the point I'm trying to get across here is that when you make those long-run decisions, that then locks you into a particular way of producing that then determines the structure of your short-run average cost curves. Now, why does all this matter? You might be wondering why all of this matters. Well, all of this matters because one of the things that we're interested in is how do costs of production change in the long run as firm size changes. And in fact, we can show that that U-shape of the long-run average cost curve isn't due to increasing and diminishing marginal returns, but it's because of the way costs change as firm size changes. And this is related to the concept of economies of size. Now, different authors call it different things. Some authors, including the author of the textbook, talks about economies of scale. That's not entirely correct. This is a different concept compared to economies of scale that we talked about in production economics. So I always make reference to economies of size. And all economies of size does is it measures the percent change in costs resulting from a 1% change in output. Now that's a pretty complicated thing to actually measure, and so we actually characterize it in terms of the shape of the long-run average cost curve, because that's a little more intuitively appealing in terms of how we might be able to use it. So we actually have three different types of economies of size. One is increase in returns to size. The author of the textbook calls this economies of scale. Increase in returns to size implies that the firm's long-run average costs are decreasing when a firm expands its production. That is, you're on the part of the long-run average cost curve that's downward sloping. Well, you might be wondering, why would this happen? What is it that's happening that would cause that kind of effect to happen? Why does increasing my level of output along that long-run average cost curve lower my cost of production, or my average cost of production, beg your pardon? Well, there's a couple of reasons. One is a physical reason. If you think about doubling a farm from 400 acres to 800 acres, it doesn't take twice as much labor to run that larger farm as it does that smaller farm. You could also think about indivisibility of inputs. And the idea here is that a larger farm or a larger firm could take advantage of larger equipment and more readily than a smaller farm. And so maybe instead of buying two 500 horsepower tractors, you buy 1,000 horsepower tractor, or a 1,500 horsepower tractor, and one that's got a lot more power and allows you to actually undertake the activities on that larger enterprise in a quicker amount of time. Specialization of effort and the division of labor is also important here. Larger operations tend to see more workers specializing in one particular task or a defined set of tasks. And through that specialization, those workers then become more productive. And one of the lessons that we learned from Adam Smith is that when you have that specialization and division of labor leading to increased productivity, you get more output from the inputs that you're using. Lastly, there could be pecuniary factors associated with size. And the idea here is that often when you get to be a very large enterprise and you're doing bulk buying, you get to take advantage of volume discounts on the purchase of inputs that lowers your price that you pay for those inputs. And so as you become larger and larger and larger, you might be able to extract a larger and larger discount on the inputs that you're buying, and that could impact on your average total cost of production. In particular, it would lower your average total cost of production. Now, increase in returns to size can't continue forever, and in fact, at some point it's going to stop. And the existing empirical evidence from decades of research would suggest that we can't take advantage of increase in returns to size forever. If we could, we wouldn't see a lot of small farms anymore. In fact, we would see one large farm, and the reason for that is that one large farm would have a very, very, very low cost of production. And it would be a natural tendency for entrepreneurs to try to gravitate to a larger and a larger farm. As that happens, you end up seeing fewer and fewer farms until such time as you've got one just ginormous farm. Well, we know that's not true. We know that's not true. And in fact, increased returns to scale does end at some point. And eventually the firm will enter into what's called constant returns to size. Here, a doubling of output doubles the cost. Now, one of the consequences of that is that long-run average cost is constant. That is to say, you hit a flat spot on the long-run average cost curve. There is a lot of evidence, heaps of evidence in fact, to suggest that this happens in agriculture, and that the region of output, the region of production where you have constant returns to size, is fairly wide and covers a long range of outputs. And in fact, in practice, much of the existing empirical evidence from agriculture suggests that the long-run average cost curve looks more like an L. That is, you take advantage of increasing returns to scale, and then the long-run average cost curve flattens out. So the idea here is that long run average cost is more like an L than like a U. Lastly, we have decrease in returns to size. And here, your cost rises, your output expands. One of the consequences of this is that your average cost rises as output increases. And the notion here is that after some point of operation, you might encounter technical inefficiencies in the production process. Either labor becomes more hampered because of how big the operation is. It could also be that managerial abilities needed to coordinate different activities on the farm are such that you can't manage with the existing set of managers, and in fact you end up with some inefficiencies. This is often why we see large corporations forming divisions and having those divisions act in a somewhat autonomous manner, because it's the breaking up of that managerial responsibility and trying to coordinate the activities that leads to greater efficiencies and helps to avoid the notion of decrease in returns to size. Another reason why we sometimes see decrease in returns to size is that machines might become less efficient beyond a certain size, or it might be more difficult to move around or to operate with a particular setup of machinery that's designed for a very large operation. Now, to get across the notion of increasing returns to size, constant returns to size, and decreasing returns to size, let's revisit the long-run average cost curve. And so that's what I've drawn here is a U-shaped long-run average total cost curve. And what we see are three different regions, well, really two different regions in one point. We have a region where the average total cost curve is decreasing in output. That's the region where we see increase in returns to size, or as some call it, economies of scale. We have a point on this long-run average total cost curve where you're at the minimum of long-run average total cost curve. That's the point at which constant returns to size occurs. And then we've got the region where you've got decrease in returns to scale, where average total cost is increasing as output increases. We're going to talk a little bit more about some examples of this in agriculture, both in the modern context and also in the context of developed and developing countries, to try to illustrate some trends that we see in agriculture, namely why we see larger and larger and larger and larger farms. That's it for now. I'll see you in class.